Up to this point, we've been working with equations that are in what's called function form, so something that looks like this. So you have a y and an x. So you graph it on an xy plane or a rectangular coordinate plane. This is called function form, and this is what this graph looks like. Now what we're going to start doing in this chapter is graphing things, introduce another parameter into this equation. So if you look at just this equation in function form, the only information it gives you is for a particular x value, what's the y coordinate that matches up with it. Now let's say this is talking about the path of a particle. What if we wanted to introduce a third parameter, like I want to know at what time is it at this particular point. So when you introduce a third parameter into the equation, it's called a parametric equation. So these are the two parametric equations that actually give you the same graph as this. So notice that your third parameter here is t, which stands for time. So if I wanted to know what happens at time t equals 0, when I plug it in for here, I get x equals 0, y equals 0. If I plug in t equals 1, your x is 24 square root of 2, your y equals negative 16 plus 24 square root of 2, whatever those values may be. So it gives you an extra piece of information. So it gives you the x and the y coordinate and the t values that match up with it. Okay? You can also do this on the graphing calculator. If you go to your mode, you should all be in function mode at this point, but what I can do is move over to PAR, and that will take you to parametric mode. So you want to press enter to highlight it. Now when you go to your y equals screen, you are going to go ahead and see your x of t, which is your x equation in terms of t, and your y of t, which is your y equation. And when you type in the equation, so let's say I want to type in 24t square root of 2, if you just press the x comma t comma button, it will automatically give you the t and then square root of 2. And then you can do the same thing for the y equation. And when you graph it, it will give you the same graph. And then when you trace it out, it will give you the x and the y that matches up. Okay? The only thing you want to be careful about is in your window, notice that your t values are there. So I'm going to make my t go from 0 to 10. Time is not negative. But you want to make your t step small enough so that it gives you enough points. Because if you make it too big, like it only goes up to 2, when you graph it, it's not going to have enough data points to figure out what the entire curve looks like. So in your t, make it pretty small. You can even do 0.1 so it gets a nice smooth graph. Okay, you can read the rest of the page through on your own. Now the first thing we want to be able to do is we want to be able to go back and forth between a parametric and the rectangular or the function form. So first thing is, if I give you two parametric equations, can you graph it either with and without a calculator? So kind of thinking back to algebra, if I give you two parametric equations and I want you to graph it from negative 2 to 3, you can make a table of values. So for every t, there should be a matching x and a y. I'm going to just go up by 1. And you can plug it in individually to each piece to find the matching x and the y. Or you can also go ahead and look in a table. So go to your y equals. I'm going to type in my x parametric equation, which is t squared minus 4. I'm going to type in the y one, which is t divided by 2. Go to your table now, and notice now your table gives you the t parameter. So I'm going to plug in negative 2, negative 1, 0, negative 1, oops, positive 1, and then 2 and 3, and then it gives you all the x and the y values that match up pretty quickly. Okay, so if you plug this into your table, it looks like this. So for any value of t, you can find the corresponding x and the y. Okay, now let's say I want you to come up with the rectangular equation. So what that means is you want an equation with just y's and x's. We're going to try to eliminate that third parameter, which is t. So I'm going to go ahead and solve this equation for t. So x plus 4 is really t squared. So plus or minus square root of x plus 4 is really t. If I take that and plug it into my equation for y, so replace that t, so y equals plus or minus square root of x plus 4 over 2. This is the rectangular equation And I got this by eliminating that parameter t. Okay. For the next couple of problems, I'm going to have you just go ahead and type it into your calculator to look at the graph to see what it looks like. But we're going to go ahead and rewrite this in rectangular form. So again, I need to solve this for t to be able to get rid of the parameter t. I'm going to square both sides. Get this. Cross multiply. Solve for t. Subtract off the x squared and then divide by the x squared. So there's my t. Now I can take that t and plug it into this equation. So y equals 1 minus x over x squared all over 1 minus x squared over x squared plus 1. It looks very messy. Simplify, combine like terms, all that kind of stuff, and you should get all the way to here. Okay, number 3, same idea. Solve for our t. So x plus 1 over 2 equals t. I'm going to take this, plug it into my y equation, so y equals 1 minus x plus 1 over 2. There's my rectangular. Number 4, x cubed is t, so y equals 3 minus x cubed, quantity squared, which is really the same as this. Okay, if you look at number 5, notice you have a third parameter. It's not t this time, it's theta. So your third parameter is just your third variable that you have. It doesn't have to be t, it could be theta as well. Okay? But this one, if you try to solve for theta, you're going to run into your inverse, cosine, inverse sine. There's an easier way to do this. Basically, when you have equations with x's and cosine and y's and sines, this is either going to be a circle or an ellipse. So I'm going to go ahead and solve this for cosine, and you'll see why in a minute, and solve this for sine. So I know the identity that sine squared plus cosine squared theta is equal to 1. So this is an identity from pre-calc. So now, since I already know what the sine of theta is, if I replace all of that, I get y over 4 squared plus x over 3 squared equals 1. And this is really the same as x squared over 9 plus y squared over 16 equals 1. Okay? And I know that this is going to be an ellipse. Center at 0, 0, go 3 to the right, up 4, down 4. So this is my ellipse. So there's my graph. And sometimes I will also ask you for the orientation. The orientation is as the third parameter increases, which direction is it moving? So you can do it just in your head. So if I plug in theta is equal to 0, I will start at 3, 0. And then you can plug in like theta equals pi half and see what the corresponding x and y are, and the next point is here. So this is called your orientation. It's the direction that the graph is moving, and all you need to do is draw an arrow there showing me which direction it's going. You can also do it on the calculator. So go to your y equals screen. So we can do 3 cosine theta, or t. The y equation is 4 sine of t. Okay, I'm going to go from 0 to 2 pi for my t. And if you look at the graph, I'm going to look at it on a standard window. Notice it starts to the left and goes this way, so you can see the orientation on the calculator as well. I'm going to do the same thing with the last one. Again, I see sines and cosines, so I'm going to solve for cosine and sine. X minus 3 over 2 equals cosine of t. Y plus 1 over 3 equals sine of t. I know that cosine squared plus sine squared equals 1 always, so in order to eliminate that parameter, I can do this plus this, equals 1. Okay, I can simplify it. X minus 3 squared over 4 plus y plus 1 squared over 9 equals 1. And again, that will be another ellipse. Center is at 3, negative 1. I'm going to go 2 to the right, to the left, up 3, down 3. There's my ellipse. And again, I want to draw an arrow showing the orientation. You can plug in a point, but it also goes counterclockwise.